isosceles triangle, we don't know if we have this as the isosceles triangle, if the exterior angle is, let's say, angle 1 right there, or if this is my isosceles triangle and the exterior angle is angle 2. Because here it's exterior to a base angle, right? Here it's exterior to the vertex angle. So it says an exterior angle of an isosceles triangle has measure 110. So if this is 110, in this situation, then what does this base angle here have to be? 70. And if that's 70, what's this one have to be? 70. And then what's the vertex angle have to be? 40, right? So it says if the exterior angle of the bases is 110, then the measure of the angle of each base is going to be 70. And the vertex is 40. Okay. The next thing, once I type that in, so 40 there, the next time when I type that in, so it's going to populate with the second part of the question, and it's going to say, what are the options if the exterior angle of the vertex angle is 110? So if this is 110 here, what is the vertex angle going to be? 70. And now how many degrees do I have left over for these two angles down here? I have 110 left over, which should match to the remote exterior angle theorem as well, or remote interior angle theorem. But if they're going to add up to 110, but what was the feature about base angles in an isosceles triangle? They're the same. So what do I do with 110 then to get divided by 2? Should give me 55 and 55. So that's all predicated on whether we know that 110 to be an exterior angle to a vertex angle or an exterior angle to a base angle. Does that help? Anything else you guys want to talk about? Say 9? Number 9. All right, so if we've got these two triangles that are providing us that information, okay, and they say that triangle DER is congruent to blank. So if I go DER, that's D to E went down 3 marks, right? And then R went down 1 mark. So I got to follow the same path over here. So down 3 and then down 1. So where have I got to start over here? N and go where? O, and then I'll finish at M, right? So N, O, M. So now the next part is basically just trying to get us to realize that they could have named this first triangle DER. They could have named it anything else. They could have named it ERD. They could have named it RED. They could have gone DER, ERD, EDR. There's a lot of different ways, right? But if they rename it as ERD, now you can go back up to the picture and say, okay, well, if they went ERD, that was down 1 segment and then down 2, right? So where have I got to start over here if I'm going to go down 1 and 2? I got to go down 1. So what vertex do I start at? O, N, or M? So I went down from E to R to D, went down 1 mark and then 2 marks. I got to start at O, M, and N. Now, that's one way you can do it by looking at the picture. I don't do it that way. I say, okay, they go DER here. We already know if this one's right. This first one was right, correct? So then they just put E first. Well, what did E? So they take that E and they put it first over here in this name. What did E match up to over here? O. So I'm going to put O first. Then make sure you do capital letters with this kind of stuff. It matters. Okay. Then they went and said R second. So R was the third letter here. So find the third letter there. So I'm going to go M. And then I'll finish, obviously, then at N, right? And that's the same thing that we got by looking at the picture. Okay. So now by using a system of equations along with following information, solve for x and y. So remember with a system of equations, you have two equations that have x and y in them, and then you want to add the equations together so that either x or y cancels out. I'm just trying to hint there that you probably want to use the elimination technique, but you don't have to. If you want to use substitution, you can. Okay. But in doing this, they give me this information. Okay. So they say angle M, angle R, angle E, and angle O. Well, do I know? So if I look at my information in my congruency statements, what is angle M? What is that 60, which is this third letter? What is that going to be congruent to? What is M? What is angle M right here, third letter? What is it congruent to over here? R. So I'm going to take M and R and set them equal to each other. Does that make sense? Now we can say, is E and O, are they congruent to each other as well? Okay. So I'm going to get 2x plus 2y equals 60. That's by taking M and R, set them equal to each other. And I'm going to get x plus 3y equals 50 by setting E and O equal to each other. Okay. Now, like I said, it's your option. Do you want to solve this using a system? You want to solve it, or this is a system. You want to solve it using substitution, or you want to solve it using elimination? I think it's set up right now to be pretty easy using elimination. What variable would be easy to eliminate here? The x, right? If I multiply everything by a -2, does that turn that equation into -2x minus 6y equals -100? The top equation, I didn't change that, so it's still 2x plus 2y equals 60. And we're going to add straight down. What happens to my x's? Cancel out. My y's give me -4y. And then my constants give me -40. Y then is 10. Does that make sense? Okay. I'm going to come back into one of my original equations, because I know what y is. I'm going to go back into this bottom one, x plus 3y. So y was 10, so 3y would be 30. Does that end up giving me x to be 20? And that's, I think, the fastest way of doing that. Okay. Once you find that, then you go find measure of angle D. Okay. Well, in order to do that, I'm going to go back up to my picture. If I know the measure of angle D, okay, but I don't have D as an expression here, right? But do I have E and R? If E is 50, and R is 2x plus 2y. So 2x would be 40, right? 2y would be another 20. So those two added together, so this right here would give me 60, correct? Does that make sense to everybody? So I know E was 50. I now know R was 60. So that's 110 degrees, correct? So what's angle D got to be? 70. Okay. There's other ways of doing this algebra here. Okay, you could have solved or eliminated the y's. You could have substituted. You could have solved this bottom equation for x and substituted into the top one. Did you guys ever use matrices last year in Algebra 1? Let me. I think the algebra is important, and you're going to be required to use that type of algebra on, like, the end of course geometry test. Okay, but if you go to Desmos, and I'm going to give this to you as a tool that you use responsibly. Okay, because it will not be available to you on the end of course exam, and if they ask you to solve a system, you need to have the ability to do that. So this is just hopefully to check yourself. If you go to Desmos, when you go to Math Tools up here to drop down your calculators, you see the one that says Matrix Calculator? If you click on that, okay, it's going to ask you, and it's really easy to set this up. They're going to ask you to identify the matrix that we had in that previous problem. So let me, it disappeared. Did I close that? Here's the information. Okay, so here is the matrix. So what it allows, if I hit new matrix, you see that it gives me this arrangement of zeros right now. What I'm going to do is I'm going to ask it to add one more column. So I want 3 things across in 2 rows. Okay, 2 rows, 3 columns. Is everybody okay with everybody? Now all you have to do then is, if you've got your system set up so that your x's are on top of one another, your y's are on top of one another, and then your constants are on the other side of the equation, a matrix allows us just to type in the coefficients. So I'm going to type in a 2, and then my 60. So that represents right now 2x plus 2y equals 60. Is that okay? And we'll do the same thing on the bottom. The bottom one was 1x, 3y, and this was 50. I'm just going to hit enter. Okay? Basically what a matrix allows us to do, it's going to do the elimination for us, but it does it without the variables. I've got to remember that this first column was x's, this was y's. And now all you're going to do is you're going to come down here, you see this button where it says RREF. It stands for Row Reduced Echelon Form. Not that that matters, but we're going to click it. And then we name this matrix A. And when I do that, it gives me this. And what this means to me, it means that 1x, because that was the x column, right? The way I read this top row is 1x plus 0y's is equal to 20. Well, then we come up with x to be 20. And this says 0x's plus 1y is equal to 10. And we found y to be 10. Does that make sense to everybody? So that can be a way for us to do the system or solve the system a little bit faster if you want to. You should be able to do that with any system that you come across. If they cross, if the 2 lines algebraically cross, graphically cross, setting up a system like this will work. Does that make sense? And you can use that on your tests and quizzes. Anything else? Any other problems? 58, yes we can. All right, find the value of the variable in the measure of the angles whose degree measure is noted on the figure. Okay, so this is just, so what I like to do from time to time is like cyclical or spiral problems, meaning that this may not have come strictly from Chapter 4, but it might have been something like towards the end of Chapter 3. I think it's something, because it's going to come up over and over again throughout the year, that we need to be able to retain this information. So what do you know about this angle out here? What do we call that angle on the outside? What type of angle? Based on its location. It's an exterior angle, okay? And what do we know about exterior angles compared to the inside angles that we call interior, right? And the ones that are far away, which we say remote. Okay, so I'm going to take 13x plus 13, and that is going to be the same, that's the exterior angle, that's going to be the same as the 7x minus 3 plus 70. Okay, you add the remote interior angles together, and that's going to produce then that same measurement for the exterior. Subtract 7x from both sides, so give me 6x. I'm going to, so this will be 67. Then I'll subtract 13 from that, so give me 54. How many times does 6 go into 54? How many? Nine. Right? 27 times 2 is 54. So if x is 9, is that all they asked, or they want? There's 2 parts, so they probably want these remaining values. So let's go ahead and plug in. So if x is 9, so this would be 7 times 9. What's 7 times 9? 63 minus 3 would give me 60. Okay. If that's 70 and this is 60, what's this angle right here going to be? What's 70 plus 60? 130, so this angle has to be 50. And then this angle here would be 130, right? Okay? I hope. Okay. Anything else on there? 51? Yeah. Let me pull this one off and we'll do it in OneNote, be easier. Yes. All right, so the first part says graph these points. So let me, hopefully that's not one that's creating issue in graphing. So -5, -6 is A, B is 1, -3, so that's not it. C, so C is going to be my option here. So let me cut and paste that because I think I'll need at least a picture for organizing my work a little bit. All right, so it says graph those. Label C is the intersection of AE and BD. It says find the slopes of AE. So I'm going to find the slope of AE. So I'm going to use A, which is at -5, -6, and E, which is at -2, 3, right? So all I got to do, remember, slope is y2 minus y1 over x2 minus x1. Okay. Now I'm going to be thoughtful of this because I also know that part D is asking me to find distance. So if I'm finding slope, then in that distance should be a quick conclusion, okay, or a quick analysis of the slope can get me my distance. So I'm going to go y2, so I'm going to go 3 minus -6. So 3 minus -6, and then -2 minus -5. So 3 minus -6 gives me 9, and then -2 minus -5 gives me 3, right? Okay. Now, the only thing that I would be cautious, because that is going to go back and give me a slope of 3 if I reduce that, right? So everybody okay with that? But I want to leave that, and then when I type it in, I got to type it in as a slope of 3. But I'm going to use the unreduced version to find my distance. Because remember, the distance of AE, it's x2 minus x1 squared plus y2 minus y1 squared, right? And if I can find that distance, so x2 minus x1, isn't that the 3? Does that make sense to everybody? So what is 3 squared? It's going to give me 9. And then the y2 minus y1, well, that's that 9 right there. It's my numerator. So then I'll take 9 squared, which would be 81. So we get 9 plus 81, which gives me a radical 90, correct? Does that make sense? Okay. The reason I'm going to do it that way, because if I reduced it, I'd have 3 over 1. I would have a 9 plus 1, which gives me radical 10. And radical 90 and radical 10 are not the same thing, right? So if I'm going to use my slope to help me find my distance, then I'm going to make sure that I use the unreduced version of my slope to do that. Now, why does that work? Well, think about this. If I'm going A to E, isn't it A to E? Isn't that rise over run right there? That black marking? Well, is that the legs of a right triangle? Make sense? And if this is 9 and that's 3, I go A squared plus B squared equals C squared. That's exactly what this is doing for us. Okay? So that's the slope of AE. Then I want to find the slope of BD. So slope of BD is going to be those two. So 0 minus negative 3, and then negative 8 minus 1. So 0 minus negative 3 is 3, and then negative 8 minus 1 is negative 9. Okay, so when I find the distance of BD, it's going to be that number squared plus that number squared. Gives me a radical 90 again. So what's that tell me about BD and AE? BD and AE, are they the same? Okay. Same length. What about, it says, find the slopes AE and BD. How would you describe angle ACB? ACB. How would you describe that angle right there if you know that that slope is 9/3 or positive 3 over 1, and that slope right there is negative 3/9 or negative 1/3? How do these two fractions, that one there and that one there, how do they relate to one another? Are they the same fraction? They're not the same, right? Are they flipped? So what do we call them if they're flipped? Starts with one. They're reciprocals. Is one positive and one negative? So they're opposite sign reciprocals, right? If they're opposite sign reciprocals, what's that tell you about how these two lines intersect? To make them perpendicular. So we should know that those two angles are right angles. Okay. It says write equations for AE and BD. Okay. So for AE, so I want the equation. So I'm going to write EQ in, and I'll say AE. Remember, when we write an equation, we're going y minus y1 equals m times x minus x1. And now I'm looking at A to E, so I'm looking at that line right there. Okay? Now, there's 3 points on it that they're giving me, right? A, C, and E. But if I look at C, is C a point that I kind of have to guess where it's at? But A or E, they're happening right there at those crossings of those grid lines, right? So when I use x1 and y1, I'm going to use either A or E, because I don't know where C is. And I'm actually going to use this information to find C in a moment. Okay, so I'm going to use, let's just use E as y1 and x1. So it's going to be, what, -2 and 3. So x was -2. So it's x minus that. Y is +3, so it's y minus 3. And what was the slope of AE? We said it was 3, right? So I'll put a 3 here. So I get y minus 3 equals, so this is a positive there, so it'll be 3x plus 6. Add 3 to both sides to get y equals 3x plus 9. So there's the equation of AE. All right? Now we want to do the same thing for BD. So BD, I'm going to go y minus y1 equals m times x minus x1. So y minus y1. So again, I'm going to use, I think D makes sense here to use as x1, y1 because it's got a 0 in it. So I can go y minus 0 equals m, which was -1/3, and then x minus -8. So y equals -1/3 x minus 8/3 will be the equation of that line there. Does that make sense? Okay, so that's what they're asking for there. The reason they're doing this, what we're going to find out is that once we find all these distances, okay, when it says AB, that distance there, and ED, that distance there, or DE, they're going to be the same. AB, let's see here, BC, that distance there, and DC, that distance there, they're going to be the same. Okay, and then we can say that these two triangles are congruent by hypotenuse leg. That's what they're asking for to justify. I'm not going to give you, there's a lot of work there, a lot of algebra that we have not spent a whole lot of time on. So I'm not going to give you one like that tomorrow on the test, but I think it does serve a purpose to talk about. We will come back after our break, and we'll focus on this type of geometry for probably at least a week, and getting more proficient at that. Because this is like where most of our geometry facts are used, like in the real world, and like you guys know what CAD drawing is and stuff like that, computer aided drawing, how those programs work, creating blueprints, that kind of stuff uses a lot of this type of algebra or geometry and algebra. Anything else? 77? I think it only goes to 74. Yes. So I'm just going to have it show the completed problem, and it goes through. Obviously, we can plot them, find the slope of these things. So when we find these slopes, you see the slopes are opposite sign reciprocals here, so they are perpendicular. So we got a right triangle. Says what is the equation for AE? So they give me these two equations. Those have been what we found for AE and BD. It says what are the coordinates of C? So when it asks for the coordinates of C, what you're going to set these two things equal. You're going to set that equation equal to that one and solve for X. And then you'll be able to solve for Y. Now give us 3, -5. When it wants us to find AB and ED, we'll use the distance formula, gives us radical 58. When we do BC, and DC gives me radical 29. So then when we go back and look at that information, just like the last one we did, they're going to tell us in this picture, we figured out that these two angles are right angles where my cursor is. We find out that AB, that distance there, and that distance there, ED, are the same. So those are the hypotenuses. And then we find out that DC right there and BC right there are congruent through that work. So we would have hypotenuse leg there. So that's the idea. So this is a long, drawn-out process. But the goal is, from all that information, I should be able to give you 4 points and determine these two triangles, and you be able to tell me if they're congruent based on algebra. And once you have that information through the algebra, does it align with hypotenuse leg? Does it align with side, angle, that kind of thing? So that one's hypotenuse leg. Anything else? Well, if you come up with, as you guys are, I'm just going to let you work on that for the remainder of the period. Okay, you can bounce ideas off of one another, questions off one another. I do want you working on it. Okay, so if you have not started it and have not finished it, please use this time to get though, because that's going to be, those are added points, right?